In this exercise, we have to compute the volume of a solid of revolution, and we start off with two functions in the xy plane, y equals x squared and y equals 2x. It would be nice to have a picture. Here's a picture I borrowed from somewhere, and there's two curves here, well, a curve and a line. This one must be the y equals x squared, which is an upward facing parabola, and this one would be y equals 2x, which is a straight line through the origin, which we can identify, so we know which is which. And I've already done some of the work for you, because I needed to know these points, and these points were obtained by solving two equations in two unknowns. And here it was, let's say, y equals x squared and y equals 2x. This is too simple for me to go in any detail, but what we do is we equate x squared equals 2x, and then we get two solutions, x equals 0 and x equals 2, and each of them we can substitute into one of the two equations. Let's say the 0. It doesn't matter which one I substitute it, I get y equals 0. And if I substitute x equals 2, I'll get 4 either here or here. So this is 2, 4. And the area bounded by them is the one that's been shaded in yellow. And now we have our basic shape. What we do with this is we revolve it around the x-axis. So this yellow is kind of revolved around, and that gives us a volume, a solid of revolution. And there are two main methods of solving it. One is essentially based on vertical slices where y is a function of x, and the other is based on horizontal slices where x is a function of y. The vertical slice method is the disk method, and the other one is the cylindrical shell method. And let me give the formula for both, because we're just working straight off a formula. Let me give myself a bit more room. I'm going to just move this picture a bit, maybe shrink it a little bit, and that should do. And now I can bring in the formulas I need, and here they are. But it's going off the page. I'll make some adjustments. I'll move the labels here. And now I realize that the top one is the 2x and the bottom one is the x squared, so I think it's better if I write them the other way around here. And actually, I don't really need this little picture, but I do want to remember that it's 0, 0 to 2, 4. So I'll just write those points here, just to remind myself, from 0, 0 to 2, 4. And there we are. Okay, everything fits in now. And we're going to do the two methods. We'll start with method A, the disk method. And we have the formula here that v equals pi times the integral from a to b, the upper function squared minus the lower function squared dx.